Another limitation to growth is temperature. Life processes are restricted at 0 degrees Celsius and above 55 degrees Celsius. Okay. Photosynthesis optimum range is between 8 and 18 degrees Celsius. Okay. So it seems kind of strange to think that photosynthesis it maximizes at 18 degrees Celsius, which we obviously know in the summertime we can in Ontario we can be seeing temperatures up to 30 degrees Celsius and above that. So why does photosynthesis plateau at 18 degrees Celsius when really we're talking springtime temperatures here? Summer can be much hotter. Seems like a legitimate question, and the answer to that is that because when the temperature gets hotter than that, what ends up happening is that the tree is losing more water through transpiration. Okay, because of the amount of heat that's taking place. There's more water loss there, so the tree is actually working harder when it gets hotter. At that temperature range between 8 and 18 degrees, it's able to produce photosynthesis, but it's not losing or having the water loss because it's not as hot to be, transpiring as much. Oxygen is critical for plants and trees, and it's not always something we think of oxygen as a byproduct of photosynthesis, which benefits humans, but oxygen is still a part of life for trees. So there's gas exchange within the bark, lenticels, leaves, buds, roots, lots of different parts of the tree. Oxygen within the soil is another critical component for the roots. And when it's not available to the roots, when it's limited, there are a lot of species that will not be able to tolerate the conditions. So saturated soils, for example, or compacted soil in urban areas where there's not a lot of oxygen is difficult growing conditions for a lot of species, because it often ends up creating these anaerobic growing conditions. A few examples, though, of some champion species and how they are able to survive these tough anaerobic conditions or lacking oxygen are in the following slides. Have a look. Okay, pneumatophores. That is these funny, spongy, spiky-looking growths coming up out of the water here. These are mangrove trees, and the mangroves are trees that look like they grow right in the water. Okay, sometimes the tides may be high and low, but other species are pretty much non-existent in these growing areas. And this mangroves wouldn't be able to grow here either if it wasn't for the pneumatophores. What they're doing is they are shoots, if you will, that come up off of the root system, and their purpose here is to take in oxygen to help the root system breathe, because otherwise they'd be completely drowned and saturated by the water. Prop roots is another example. This does a couple things from a biomechanics perspective. Prop roots help to support the tree, but also provide more rooting mass and rooting area. And you can see the growth. They're quite fascinating that the meristematic tissue will specialize to become root systems instead of branches or foliage, find their way down to the root system and create greater rooting surface area as well. So quite interesting. Adventitious roots. So here is an example in the greenhouse. This was a willow cutting, so it would have been cut right approximately there. In the spring, dipped in some rooting hormone, placed into a mist bed, and we see this wonderful mass of nice roots that have grown off of that cutting. Okay, adventitious roots here help to keep this plant alive, but also adventitious roots can be used in areas where the surviving roots, or sorry, the roots that may have been killed off or being saturated, will get support by the tree producing these adventitious roots to carry on some survival. Okay, another limitation is carbon dioxide. However, it's generally not a limiting factor. Okay, photosynthesis increases with increased amounts of CO2. So some species may survive in lower light intensities in the understory due to carbon dioxide produced by what? If we think back to that few previous slides, I drew out a rough sketch that looks something like this in the forest, and all this understory litter that's being decomposed by microorganisms exchange gases. Okay, they give off, remember, CO2. Okay, so there is lots of CO2 in the atmosphere. So even right here within the forest floor, sometimes understory species which may not be getting a lot of sunlight to be able to produce photosynthesis, they take advantage of the CO2 that is being emitted from decomposition because they're so close to the forest floor. Okay. And finally, are there any other factors that may limit growth? If we go to the urban setting, and unfortunately not always just the urban setting, but depending on the jet stream and where the pollutants may carry, pollution is a limitation of growth as well. Okay, just depending on the type of pollutant, the amount of pollutant, how it's influencing the tree. It's very obviously complex, but pollution plays a major role in limiting good sites for growth and the success of trees on sites as well.